We will start in few minutes. We'll wait for some more time so that people can join. In the meanwhile, can you confirm whether my slides are visible to you and I'm audible to you guys? Thank you, Divyansh. Hi, everyone. We'll start in a short while so that more people can join. In the meantime, uh, either you can unmute or you can drop a text in the chat box. Just give a brief introduction about you, like what is your name, from where are you, what you guys are doing. Hi everyone, my name is Himanshu Singh. I'm a PhD student at IIT Kanpur in VSB department. I would appreciate if you all can just drop a text in the chat box or you can unmute whatever you are comfortable with. Just let me know what you guys are doing. If you are a student, of what you are a student, which year, and if you're not a student, and in which profession you guys are. Let's just start on bit informal discussion for today. And yeah, how was your week? Since we are waiting for others to join, let's communicate. Cool. And I hope you guys are keeping up with the course and the video lectures weekly, and you guys are doing good in your assignments. Anyone drop a text, at least your name and which program you are enrolled in, anything. Oh, okay. Nice. Thank you, Divyansh and Rohansh, for your kind introduction. Okay. I think I'm pronouncing it right. I hope so. Dundavya, Dava, right? Dundava. And if I'm not pronouncing it right, I'm so sorry. Thank you for your kind introduction. Okay. Oh, we have diverse field. Right. Nice. So how are you all guys keeping up with the course? Is it going good? Are you guys learning on daily basis? Or at least like with respect to this course only, are you learning new things? Thank you, Kamal, for your kind introduction. Oh, okay. We have live sessions, Rohan, for these only. I hope the assignment questions which we discussed in the week prior to your submission helps you in solving the questions. Hi, Sujata. Thank you for your kind introduction. Yeah, it will. See, we are, I guess you guys, right now, you guys are on fifth week of the lectures, right? Of Professor Mandal, like the lectures which are available to you is the fifth week lecture, I think so. Yeah, you are already more than half of the course you guys have covered successfully. And please do register for the certification course if you are planning to, because you are already putting so many hours for a course. So it's better to get a certificate out of it. And for those who are, and mostly, as I can see, mostly they are students. So you can transfer these credits to your actual mark sheet, which will help you in covering all your credit requirements, and you can do extra, you can get brownie points for it also. So yeah, make sure to register for the certification and give the exam. And the exam chances are it will be similar to your assignments, because see, most of the problems which we are solving in the assignment are the problems which are generally related to this subject. So you don't need to worry much about it. Just keep up with the pace of the class which Professor Mandal is taking, and attend the live sessions either with me or the session which is organized on Sundays, I guess, Sundays evening. Just try to attend these. You don't need to put any extra effort if you are being very, what to say, very regular with the online classes as well as the discussion. And if you have any query or doubt, you can always drop me a query. I have given my email address in here. And I hope that you guys are able to access the slides which are discussed in the live session. Is it? You guys have the access to the slides, right? And the video content of the live session. If not, then I can just drop the YouTube link in the chat box for the previous week. If you guys don't have the access to the live session which I took previous Saturday, just let me know. Okay, so I think we can start. And as usual, we will give some brief introductions to whatever we have learned in the fourth week, for which we're gonna discuss some of the assignment problems. So I hope you guys remember it and you guys gonna help me in understanding and remembering what we have learned. And there is some problem with the sharing. Let me try. Okay, but this is the second slide on the post. I'm sorry for this. I myself am struggling with it. I'm extremely sorry. Just give me one more minute. Okay, I don't think so you guys are able to see my slide yet. I hope it will start sharing in a while. Okay, you guys are, what is visible to you guys? Can anyone tell me? Hello? Okay. Okay. Even now, nothing is visible to you guys? Because on my side, it is saying that my screen is visible to you guys. Okay. Thank you, Divyansh. Yeah. So, yeah, thank you. Thank you. So we will see what we learned in this week, and then we'll quickly jump to some basic questions which might help you in your solving assignment. So the first slide is basically densification of solid, and you have to help me out here. So what is densification? Can anyone brief me out? What was densification? Anyone? You can type in the chat box, or you can unmute yourself and say. Process of increase the density. Okay, okay, Rohan. And why we need to densify, or why we need to increase the density of the material with respect to the raw material? Any brief idea? What was the main reason for densification? To make it easy
Ma'am,
to process further. Yes, yes, go ahead. Someone was saying something.
ma'am, it is just to reduce the logistic cost.
Yeah, logistic cost, or we can even say that we can increase the efficiency indirectly, because, for example, if a plant is running and it requires certain amount of heat, and to generate that heat we require X amount of raw material, and that X amount of raw material can be transported via trucks or other logistics. That X, for a plant to run in a day, it requires two times the truck its visit cost that. But if we are using a product or a fuel generator which can be transported one time itself, then we can run our plant twice with the efficiency or the output. So densification is the process of increasing the density of something, as people mentioned correctly. It makes a fuel denser and gives more uniform properties with respect to its raw form. So what, according to you, can be some of the advantages apart from what is written here? You can say things what are written here as advantages, but you have to rephrase them. According to you, what you understood, if we are uh, if we are densifying the material. So what is the major reason we have discussed? So with this reason, what are the advantages of densification? Because we are putting a whole different unit operation for a process, which means we gonna input energy into uh, this process, energy, space, time, right? So it must have some of the advantages which are overpowering the disadvantages which we are currently facing. So according to you guys, what can be the advantages? For me, as Pradeep mentioned, that for me, the advantage for densification is this only, that it reduces the logistic cost and indirectly it increases the efficiency. Similarly, for you guys, according to you, what is the major advantage of densifying the raw material? Anyone? There are no wrong answers. Again, if you are scared of telling a wrong answer, don't worry. Or you can simplify what is written here. See, I'm discussing this and I want you guys to take active participation in the discussion so that you guys can get a deeper understanding of the concepts and the things. And it is not just like any other subject for you guys, so that you learn something new from the subject. This is my whole uh, effort for. So, what is meant by simplified mechanical handling and feeding? It is listed as a first advantage here. So what exactly simplified mechanical handling and feeding means? It's very basic and very logical things. Basic. You don't need to describe in terms of waste to energy conversion terminology. No worries, right? You can
Simplified,
tell.
ma'am, simplified mechanical handling, as per my understanding, is
Hmm,
just to make the some blocks or some bricks
hmm.
like this, huh? Feed
Yeah,
material.
mechanical handling
And
at the end of the day. For example, if you are putting a waste material which is very haphazardly organized, right? Because waste material is not sorted. If and you are feeding it to the machine, you're at the end of the day, you're gonna feed it to a boiler or to a pyrolyzer or to a gasifier, right? So that won't be a uniform process. On the other hand, if you have chiclets of a thing or briquettes, as we're going to discuss further, they are very easy to feed and handle, because we know what kind of a shape the briquette has, what is the storage capacity it's going to require. So we can plan ahead for all the things. Second point, uniform combustion in boilers. Obviously, if we are giving directly the raw material without densifying it, chances are the material won't be combust evenly, because we have not sorted it properly. The particle size are not uniform. It is not a homogeneous thing. Hence, uniform combustion in the boilers. And this uniform combustion in the boiler will indirectly relate to the even high calorific value and high heating value of the product. Reduced dust production. At the end of the day, we know what amount we are feeding in what volume we are feeding in. So the dust or the waste material generated from it will be under the manageable range. Second, reduce possibility of spontaneous combustion and storage. What is meant by this? Reduced possibility of spontaneous combustion and storage. Any idea? Any guesses? Not even idea. Okay, let's guess. Like, what are you understanding from this statement? Reduced possibility of spontaneous combustion and storage. I can give you all hint, though it is not a direct hint, but I think so that you guys can reach there. Have you heard in the news, not recently, but yes, earlier it used to come in the newspapers that the landfill is on fire, right? Due to the heat or the summers, the landfills are literally on fire, if you remember such thing. What happens is, if you're putting any material at the end of the day, what is this material? This material can be municipal waste or household waste or industrial waste or any other type of waste, right? So all these waste materials are what? At the end of the day, they are uh, organic in nature, chemical in nature, and whatsoever. So if they are left unattended in the open area like landfills, so due to the heat, because at the end of the day, sun is heating our surface, right, via radiation, it is also a source of heat. So what happens due to this, their the threshold is basically any bar which needs to be crossed for a process so that it can occur spontaneously or it can occur without much initiation. So what happens is if the raw material is left unattended as it is, due to the heterogeneous nature of the mixture, chances are there might be some of the material which is high in moisture content, some which is high in acid content, some which is high in, for example, organic content, right? So all these things, this heterogeneous mixture, due to the heat or other factors, such as if it rained a lot, it will leach into the ground, correct? And it will barren our land and all those stuff, some related stuff. So if such things are present, what happens is the raw material ignites itself due to the external heat and it burns. And this burning is not complete burning because we are not providing high enough energy for it to completely combust, right? So it will be a partial combustion. And due to partial combustion, some harmful gases are produced, such as monoxides of nitrogen, sulfur, carbon, right? These are not a good gases. On the other hand, they can also generate some greenhouse gases at the end of the day. So if we are densifying the material, which means we are reducing the uh, exposed area for such kind of reactions to take place at the end of the day, and hence it is at the end of the day easier for us to store. Second one, last one is simplified storage and handling infrastructure, lowering capital, we have discussed. Reduced cost of transportation due to increased energy density, we have also discussed. As every process has both advantages and disadvantages. So one of the disadvantage of densification is, the major disadvantage to biomass densification technology is the high cost associated with some of the densification processes, which means if you don't have any limitation for the amount of money you are putting in for densifying a material, it is a good technique. But at the end of the day, we have capital for a limited amount of things, because if you're putting a densifying plant or a densifying machine, it is not necessarily that all of your money will go into this, right? you are planning ahead also with the things which are made by densification. Either it can be a briquette or a pellet. You are gonna use these briquette and pellet for the energy production at the end of the day, and that energy production will be in a plant, and that plant can either be a gasifier, pyrolyzer, incinerations, and we have already discussed those processes and the different types of gasifiers in these chambers. And we know that some of them are very high quality machines, but as every high quality machine, they are very costly. Hence, we need to trade off between in which we need to put a major amount of money and in which we can compromise a bit, right? It's a very generic introduction for these things. So what is the mechanism of densification? Firstly, the first step will be compaction, compression, conservation, and then concentration, right? We will discuss everything in coming slide. So the mechanism of densification is, can anyone tell me the concept behind densification? What happens when we are compressing or uh, like providing it high pressure? What is the basic principle behind it? Why we are yes, go ahead. Someone was saying something. Okay. So my question is, why or how densification works? We have suppose 1 kg of cotton and 1 kg of iron bar. Which gonna take more space? Will it be 1 kg of cotton or 1 kg of iron bar?
Cotton.
Cotton gonna take more space, right? But if we put this cotton in a bag, which is of dimension, suppose 4 by 4, right? Similarly, the iron bar is also a bar of 4 by 4. So they both gonna take the same space at the end of the day. So what we did in the first case, what operations we performed on the cotton for it to acquire or occupy less space? We pressurized it, right? We compacted it. So what happens due to compaction or when we subject it to high pressure? The interspace, the interparticle space, as well as the not intermolecular space necessarily, but definitely interparticle space reduces. We are excluding all the voids which are there between the particles, correct? So the densification of biomass under high pressure results in mechanical interlocking and increased adhesion cohesion forces such as van der Waals of the solid particle, which form intermolecular bonds in the contact area. What are van der Waals forces? Can anyone tell me? And if you do not know how to explain it properly, okay, just tell me whether it is a, covalent type of force, or is it non-covalent type of forces? What kind of forces are van der Waals? And if you have no idea, please uh, either raise your hand or text me in the chat box so that I can explain you what van der Waals forces are. Okay, so no one is raising hand, which means you know what is a van der Waals force. So what are van der Waals forces? Feel free to unmute or chat, please. Yeah. even if you have like a brief idea about van der Waals, because it's very basic, and I assume most of you are from engineering background. So you guys have some idea about the van der Waals forces. So just give it a try and try to explain what are van der Waals forces. These are very uh, basic forces which are responsible for most of the structures for being stable in the way they are. Okay, no one gonna take a dig on it? Okay, no problem. So van der Waals forces are a type of non-covalent interaction. They arises when two molecules approach each other. And how far two molecules can approach each other? For example, we have two carbon atoms. So if they're coming close together, so how far they can come close together? Because they have electrons in the, they have electron cloud around them and a positively charged nucleus at the center of them, and they're coming together. Sharing of electrons between two similar atoms. Uh, mm, this is for covalent interactions. So in covalent interactions, we share the electron. In ionic, we transfer the electron. But in non-covalent interactions, we are not sharing electrons at all. So what happens when two carbon, suppose in this particular example, if two carbon atoms are coming close together, so what will happen? If this is the first C1 atom, this is C2 atom, right? So they have their electron cloud around them. Similarly, this one also has the electron cloud around them. And they have positively charged nucleus at the center of them. And they are coming close together because for making bonds and interaction, they need to come together. And also in solids and liquids and in the matter, they have some energy, right? Brownian moment, if you remember, for the liquids. So they constantly have oscillation energy in them. So when they're coming together, so the electron cloud of second or vice versa, anything can happen. The electron cloud of first and the electron cloud of second will provide repulsion forces, sorry, because both of them are negatively charged, right? So negative, negative repel each other. So at a certain distance, what will happen? The nucleus of first or second, again, because they both have carbon, so they have same electronegativity. So at a certain distance, what will the nuclear force will be more strong, which means the nucleus of one will be attracting the electrons of other, because nucleus is positive, electrons are negative, hence they will be attracting. But after a certain distance, the attractive force will reduce and the repulsive force will increase. Why? Because the electron clouds are getting in one and other shell, right? They are overlapping in the shells. I do not want to go deep into the atomic structure, but remember that every atom had shells, right? P, Q, R, S, which NSP we used to discuss, we used to learn. So these electrons at a certain distance, they won't be able to come any more closer together because the repulsive force will be more strong. So what will happen? This distance to which two atoms can come together is called van der Waals distance. Correct? And the van der Waals is basically the distance of in an atom from its center to the outermost electron shell. So two atoms cannot come closer more than their van der Waals distance or van der Waals radius. I hope this concept is clear. So if we are providing pressure or high compaction or any type of operation which is allowing the molecules to come further closer together, it's gonna interlock them. And hence, for example, two carbons were at this distance, they were occupying this amount of space from here to till here. But due to compaction, now they are occupying only this amount of space. Got it? I know it's a lame way to explain, but I didn't had anything else to explain you guys with. So what are van der Waals? They are non-covalent type of interactions. They are kind of electrostatic interactions which occurs due to the attractive and the repulsive force in two atoms. So when we are putting pressure, we are inducing more adhesion and cohesion forces, or the more van der Waals interaction. Hence, the molecules are closer together in comparison to when there was no pressure subjected to them. Got it? I hope I'm clear to you guys. If you have any question regarding van der Waals, please go ahead and ask. Because these are some basic kind of forces, van der Waals, electrostatic, and they play huge role in protein stability. It's out of this syllabus, out of this particular course, but I want you guys to understand van der Waals because they are huge kind of forces, though they are weaker than covalent bond, but due to their number and the quantity in which they occur in nature, they are very dominant kind of force. Got it? Okay. So again, same how we are doing densification. The material is compacted at low to moderate pressure, and the space between the particle is reduced, as I have mentioned. If pressure is increased at a certain stage, particular to each material, the cell wall of the cellulose constituent are collapsed. Here, when you are doing compaction, this completely depends upon the type of raw material you are subjecting the compaction to. Got it? If it is a suppose agricultural waste has lignin, cellulose, hemicellulose, all those kind of stuff in them. So, and these are basically carbohydrates. So if you're putting more pressure on them, what happens is, due to the enhanced van der Waals interaction, they will interlock more efficiently in comparison to when the raw material doesn't have much of organic content. Got it? Then the pressure required to achieve such high density is typically in the range of 100 Pascal. A binding agent is necessary to prevent the compressed material from springing back and eventually returning to its original form. Can you explain me why a binding agent is necessary? Indirectly, I have given you the answer while I was explaining about the van der Waals interaction. Why they will spring back? Any idea? Why we need binding agent for compressed material? As I told you, during compression, two particles are coming close together and they are increased van der Waals forces. So there are different types of van der Waals forces, and van der Waals forces are both attribute attractive as well as repulsive. So after a certain distance, what will happen? The repulsive forces will be more in comparison to attractive forces. Hence, we need some binding agents to ensure that the repulsive force would not overcome the attractive force. That is why we need binding agents. And these binding agents, most of the time, are like organic in nature, which have very high carbohydrate content. So, additives of high viscous bonding media or binders, such as tar, molasses, and other molecular weight organic liquids, can form bonds very similar to solid bridges. Adhesive forces at the solid liquid interface and cohesion forces within the solid are used for binding. I hope you guys are clear about adhesive and cohesive forces. Can anyone brief me what is an adhesive force and a cohesive force? You can text me in the chat. These are some very basic terminologies which we study in chemistry at a like at school level, I guess maybe 9th, 10th. Yeah. So what are adhesive forces and what are cohesive forces? I know you guys have idea about it, So I want you to just at least give it a try, that what you understand from adhesive or adhesion and cohesive or cohesion forces. Anyone? At least give it a try. Try to explain. And if you have no idea, then also at least raise a hand or something so that I can start explaining. You guys can hear me, right? So adhesive forces, cohesive forces. Adhesive forces are the forces between two different components. For example, if you pour water in a glass, right? So you can see when you pour the water in the glass, the surface of the water is not completely parallel to the surface of the bottom of the glass. It is somewhat curved in nature, right? If you see from the top, it will be bit of concave in nature. So why this? Because the water molecules which are at the surface of the glass, they have some adhesive forces between two substances. In this case, it will be water and a glass. And cohesive forces are the forces which are within the same compound. So here the example will be water itself. The water is liquid. Water is liquid at room temperature. Why it is liquid at room temperature? Due to hydrogen bonds. Hydrogen bonds at the end of the day, they are non-covalent bonds and they are cohesive type of forces. They are forces which are among the same molecules. Got it? Uh, Someone wants to say something? Hello? Okay. Yeah. Kindly check your mics and everyone, please mute yourself if you are not planning to speak. Yeah. So I hope I'm clear about cohesive and adhesive forces. Just drop a yes in the chat box so that I can understand that you guys are getting me. Otherwise, I can explain you in more, I can try to explain you in more easier language. You guys understood what are van der Waals forces, what are cohesive adhesive forces? Yes, no, maybe, anything. Yeah. Okay, you didn't understood. So what part? The van der Waals or the adhesive cohesive force, Pradeep?
Particularly cohesion.
Cohesion. Cohesion is basically, see, if you understood about the adhesion is the force between two different molecules of different compounds. In this example, water and glass, and I hope you understood it.
Yeah.
Cohesion will be why the whole of the water is not on only the glass surface, it is in the volume also, right? At the center of the glass, there is no glass, there is only water. There is no surface of glass in the in the center of the water glass. Uh, you got me? I don't have any. Mm.
Instead of water, can you
Huh.
give different example
Uh,
so that
Addition,
it will be
cohesion.
easy to
Okay,
understand?
what if we talk about viscosity and then we link it with cohesion? Hmm. Okay,
You can
you
take an example
understand
of molasses.
molasses, huh? Again, they both have similar density to, like molasses and honey, they both are almost similar in density, though molasses have more density. Why we are calling it has more density? Because the internal forces of the molecules which are making the molasses or honey are stronger than the compound on which they are present, right? If we are putting water and honey or molasses at a wedge, the water will flow more freely in comparison to molasses and honey. Are you able to imagine this?
Yeah.
Yeah. So why water is flowing more easily on a veg and not molasses and honey? Because water has very strong adhesive force with the surface. It is making interactions to the surface, because of which it is flowing very easily. While for the molasses and for the honey, the internal forces are stronger than the force which the molecules of the molasses and honey are making with the surface. Hence, they are not easily flowing to the surface. It is just for example, van der Waals. Van der Waals are the forces between two atoms, two molecules, right? If the interaction between these two molecules is strong, they will interact here in comparison to the molecule which is here. So if these two are closer together, instead of this molecule being closer to this surface, this interaction won't happen. Hence, they will stay together. They're staying together because the internal forces are more. And the name of that internal force, one of the name of this internal force is cohesion or cohesion.
Okay.
Yeah.
Yeah, got it.
Okay.
Thank you.
No problem. So the binding agent can either be added to the process, or when compressing ligneous material, be part of the material itself in the form of lignin. At the end of the day, lignin is also a carbohydrate. So these were different types of densified material. One is briquette, the other is pellet. The difference between them is on the basis of the diameter. As we can see, briquette has more diameter in comparison to the pellet, right? So what are the factors which will influence densification? Uh, can anyone brief me out? We have somewhat discussed some of the properties, and those properties at the end of the day will affect the densification process and the material and the action of densification, process of densification. Anyone? Uh, See, the raw material which we are using, at the end of the day, it will influence. So what are the properties of the raw material? Since week one, we are exploiting these properties, right? We are analyzing, we are measuring, we are trying to make best out of the properties which are available in the raw material. And such properties are moisture content, right? We have discussed about it in like week one and week two lectures. Bulk density, void volume, thermal properties, correct? The ultimate density of a briquette will depend to some extent on a range of factors, including, most importantly, the nature of the original material and the machine used and its operating condition. We will discuss in the coming slides these conditions and the machinery, as well as other minor factors. So at the end of the day, if we are saying it is depending upon the what kind of a material we are using for densification, the material, by saying that it depends upon the material, it depends upon the properties which that material is holding, and that properties are both physical in nature as well as chemical in nature. So among the physical properties, we have moisture content, we have density, we have thermal properties, right? In the chemical front, we have of what constituent it is made up of. Is it organic? Is it inorganic? If it is inorganic, then the ash content will be high. If it is organic, then if we are completely combusting, we will get more energy. If we are partially combusting, then we'll get gases which are not suitable for us, right? So at the end of the day, it depends upon the type of material which we are using for densification purpose. So there are different types of briquetting, as we already mentioned that the pressure and the conditions and the machinery will depend, will influence the quality of the briquette or the densification process. So this classification is based on compaction, and they are divided into three different types. First is high pressure compaction. And this high pressure compaction is accomplished by subjecting the raw material to around like 100 megapascal of pressure. Medium pressure compaction will be subjected to compaction of 5 to 100 megapascal, and low pressure compaction with a binder will be subjected to pressure of around from 0.2 to 5 megapascal, right? And why we need binders in the low pressure compaction? Because we are not subjecting it to such a high pressure that the molecules itself interlock among themselves. Hence, they will have more tendency to move away or lose their integrity and cut loose, or in this case it will be more in a like granulated or powdery form, right? So it is all very I guess it comes naturally to you. If you are putting more pressure for a thing, you don't need to put binders, because the energy provided during the pressure is enough for the molecules to stay in that briquette or pelleted form. While in when it is subjected to a lower pressure, the energy is not that enough that it will sustain the briquette and pellet for a longer duration of time. Hence, to ensure that the briquette and pellet is in that form for a longer duration of time, we need certain binders. So similar things are mentioned here. Usually high pressure processes release sufficient lignin to agglomerate the briquette, though this may not be true for all materials, right? If it is the organic material, then definitely this will be true. If it is some other type of raw materials which are not organic in nature, which are not agricultural in nature, then it won't be true. Then intermediate pressure machines may or may not require binders, depending upon the material. Then low pressure machine invariably require binders, because we are not providing enough compaction for the briquette to sustain that shape and that density for a longer duration of time. In this, we are discussing some of the important briquetting processes, for example, especially for high and medium pressure operations. So high and medium pressure compaction normally does not use any additional binder. We have discussed it, like why it is obvious that we do not need to provide any external binders. Second, normally the briquetting process bases either on piston press or screw press technology. So these two are the machinery which are there for generating briquettes having high and medium pressure, which depends upon high and medium pressure classification. Others briquetting technologies are less applicable in developing countries because of high investment. We have discussed this, that the only drawback of densification process is that the cost which is involved in this process and large throughput. So in this example, roller press and pellet mill are the two machineries which have like they cost more, but their throughput or their output is also more. But that output does not directly linked with the demand, right? Supply and demand. I hope everyone is aware of this basic phenomena of supply and demand, right? If you want to get more price of something, and if the demand is more, you can always like increase the price. But if the demand is low and you have high supply, you need to reduce the price so that at least you can get the cost of the production of the material, right? So we will discuss one of the high pressure machinery, which is a piston press. So what exactly a piston press is? Can anyone brief me? What was a piston press? Hmm. Okay. Am I audible to you guys? Can you guys tell me?
Yes, ma'am.
Okay. Deepak Kumar, I will suggest you to please leave the meeting and try to reconnect, because I guess majority of the people can hear me. So I think there is some issue with your side. This can be one thing. The other can be check your audio connection in the meeting itself. Yeah. So what was piston press? Yes, Sarvanan. Do you want to say something? Saravanan, you have your hands raised up. Do you want to say something? Tell me, ask something. Okay. Okay. I think it was by mistake. Yeah. So what is a piston press, guys? Anyone? It is very basic, very easy stuff. It is just a press which uh, has piston-like action, and that piston can be either uh, subjected by. Okay, someone is texting me. Deepak Kumar, everyone can listen to me. That is why I'm suggesting you to leave the meeting and reconnect or check your audio connection. Everyone else can hear me. Yeah. So, so piston press. What is a piston, right? We know what is a piston, correct? We have seen many engines and all those stuff. So piston presses punch the feed material into a die. Die is basically a mold here with very high pressure, because obviously we are studying densification, and densification associated with high pressure. Either mechanically by a reciprocating ram powered by a massive flywheel or by a hydraulically driven piston. At the end of the day, it will be a piston which will be providing the high pressure. The mass is compressed and forms a very dense briquette. And it is the simplified representation of the piston press. We can see here, the feedstock will be subjected here, the pistons will be associated here, and irrespective of from where we are driving the piston, the pellets or the briquettes will fall from here. I will highly recommend you guys to go and search piston press in YouTube. There are very good videos out there, and you will see the exact machine which is there, and it will help in your understanding and visualizing the machine. But what was the drawback of piston press? There was one very big drawback of the piston press, because of which it is not used in at large scale or for large scale industries. What is the drawback of a piston press? Anyone remembers? Um, okay, if not, no worries. We'll see in coming slides that what was the major drawback, and I hope that you guys will remember then. The other was screw press or screw extruder. Again, it was under high and medium pressure operations. So here what happens is, from this is the simplified representation of the screw press or screw extruder. In a screw press or screw extruder, the rotating screw takes the material from the feed port through the barrel and compacts it against a die, which assists the buildup of a pressure gradient along the screw, right? As you can see, that this is getting tapered at the end as we are moving from left to right, right? So what will happen, as the area decreases, the pressure increases, and also we are providing heat, which will further enhance the pressure. And at the end of the day, the briquettes will come at this end. This is also called screw extruder. So I don't know how many of you are aware of how the food product kurkure is made. Okay, I think most of you have eaten a kurkure, right? A pack of kurkure. So they are not fried, right? They are puffed products. like other chips product which are fried. They are not fried, they are puffed products. So in the food industry also, this kind of instrument, it is called extruder. It's a very generic term for a machine. That extruder is used in which the raw material, and in that case it will be the corn, wheat, all the masalas and everything will be subjected here. The heat will be provided here and it will be passed through a very narrow nozzle like this. The nozzle will keep decreasing, which will enhance the pressure and heat, and there will, here will be the cooking of the raw dough and the material and the masalas will occur, and here we cut them at the regular size. And as soon as they come out of the die, what will happen? They were subjected to high pressure. Here they come to low pressure. Hence, the internal of that material, the gases which are present in the material will escape, leading to the puffness of the material. So any puffed product in future, if you're gonna eat, always remember they are manufactured by an extruder. It is just a fact. I don't know how many of you knew it. Yeah. So a screw press and screw extruder uh, performance of the process, speed of densification, the energy consumption, the quality of the briquette. It depends upon flowability and cohesion of the feed material, right? Particle size distribution, obviously, surface forces and adhesive forces. So screw press produce high quality briquette with a homogeneous structure and good combustibility, requires only little maintenance. But one of the disadvantage of screw extruder or screw press is that wear of the screw leads to elevated spare parts cost, which means if we are gradually using the screw is basically like a, it is made up of stainless steel mostly. So it will be a screw or turbine like manner. So if we are continuously using it, the shredding will occur gradually because it is subjected to high heat also, right? High heat and pressure. They're not good for the material itself. So in the long run, the shredding will start, and hence you have to replace the screw at some point. And this adds the extra cost for the machinery. So this is one of the disadvantage of the screw press. Now we are talking about low pressure operations, right? So this process requires a binding agent, as we discussed earlier, to assist the formation of bonds between the biomass particle, right? Two types of binding agents are present, organic or inorganic, as we have discussed. The most important binding agents or binders are inorganic. These are the ones, and in inorganic, these are the ones, right? So during the compaction process, the briquettes are brought into shape without giving them substantial strength because we are not subjecting them to a high pressure. So after a subsequent curing step, the briquettes are developed with required strength and stability. These are just some basic things. So my question there when I asked about what was the drawback of piston press, right? It is written here. So can anyone spot what is the major disadvantage with piston press? Anyone?
High maintenance is the major drawback.
But it is also in screw press.
Screw press, there is low maintenance.
High maintenance. Oh, yeah. Sorry. I was looking for other things. For roller press and pellet mill, also there will be some kind of maintenance will be required. But press and pellet mill are not for developing countries, right? Because they cost very high. So among the products which are among the machineries which are used in India or developing countries, which does not cost much, the one thing which we can say is the output from the machine. Because in industries, most of the processes are continuous processes and not batch processes. But for piston press, it gives the output in strokes because when we are pressing the piston, then the process will occur and the pellet or the briquette will form. While for screw press, we are continuously rotating the screw and the pellet and the briquette will form. So this is one of the disadvantage for piston press, that it gives output in stroke or in batches in comparison to others, which gives output or output in the form of continuous process. This is one of the disadvantage. And even maintenance also, it is right. But if we want to run an industry, we cannot depend upon solely on the batch process in comparison to when we have options like uh, uh, a process which can give us continuous output. So these are some of the brief comparisons between the screw piston roller and pellet mill.
Ma'am,
So yeah,
I have some different say on this
okay.
total
Mhm.
matter subject.
Go ahead.
See, why we should go with the densification? Because
Okay,
uh, it has certain advantages, but the
correct.
major disadvantage is the cost,
Yeah.
and we are just considering the economical cost of the finance.
Mm,
But the
yes, kind of.
environmental cost is much more than the actual economical cost. So, is it really advisable to go for densification? Considering the
I
carbon footprint
hmm,
and the energy intensiveness, all these factors, if you consider,
hmm.
personally, what I feel that are there any less energy intensive densification processes which we can adopt, especially for the Indian smallholder farmers or the small and marginal farmers, because there it is the need.
Hmm.
We have to develop the technology or the machineries which are quite useful for the small farmers. This is my personal opinion,
Yeah, yeah, yeah.
and definitely you will also agree with me.
Yeah, yeah.
So, and considering the environmental cost, we have to find some other alternatives.
Yeah.
So,
Okay.
what is the, will
My
you please
yeah,
throw some
my
light?
in yeah, yeah, yeah. My take on this will be you are considering only one aspect of densification, that it is very costly, right? If I am at your place and I'm looking at this whole process, because my end goal is not to produce a briquette or a pellet, right? My end goal is I have a waste material which is not used for any other thing. From this, I need to generate some quality product. And here, the quality product is not the briquette or pellet, it is the electricity, fuel, chemicals, bio oils, and different things. That is my end goal. So, in that end goal, will the cost of densification overpower the quality of the product which I'm gonna deliver? If I
Ma'am,
have one, yeah.
if we'll combine the cost of environment and finance,
Hmm.
then definitely we are paying very high cost for this
For
process,
environment, how can you say? See, these pellet and briquettes, where are they used? What do you think?
because we are
Hmm.
using the electricity for all this. Am I right?
Ye- Yeah, we are providing,
So,
we are
so
inducing pressure at the end
electricity,
of the day.
yeah, electricity. Most of the traditional electricity generation is coal-fired power, right? So it is highly carbon positive, or we can say which is
High
generating
carbon
a high
footprint.
amount of,
Yeah.
high amount of GHGs. So
So my
can't we
comment here
use?
will be, yeah, yeah.
Yeah, please. Yeah.
My comment here will be, see, the end goal of the briquette and pellet was to generate energy and act as a fuel, right? Fuel for the plants from which we gonna generate our product, which I enlisted earlier,
Mm.
right? So if we are not handling the material, And here handling, I mean, we are not subjecting it for densification. We're gonna directly put the material. Maybe we are putting some pre-treatment plants and we are homogenizing it, we are sieving it, we are ensuring that all the particle size are kind of homogeneous, right? And we know why we need all those things in the material. So don't you think the additional cost, if we are putting directly raw material directly into the power plants and not subjecting it to densification, will be more in comparison to when we are putting the material in the densification process?
No,
Hmm.
absolutely, you are right, ma'am. But
Yeah,
we need to search for some alternative methods. This is my personal.
this is one way. Yeah, correct.
Yeah.
Yeah, you are completely right in this. See. Hmm.
For example, if we can develop some technologies which can be animal powered operated, like bullock power operated, the
Hmm.
screw press, which will be operated by using the bullock power or
Yeah.
as power, or in terms of any animal power.
We have other presses which are hydraulic in nature. As the name suggests, hydraulic is basically the usage of water as a source of energy, right? There are few basic components. I hope you are aware of how a engine works, right? There will be a turbine. The turbine needs energy to rotate. This rotation will be subjected to a generator which will store this energy and it will give us, right? It's a very
Right.
basic, and it depends, and
Basic,
it
yeah.
is in every industry, right? This is the process at the end of the day.
Right.
So if you are saying that it is animal powered, it can be. But if I say that the piston press or the screw press is not run via electricity, because at the end of the day, what I just need the piston to move, right?
Mhm.
And this energy for the piston to move can be from electricity, can be from hydraulics also, right?
Okay. Mhm.
So there are processes already in action where we're using hydraulics or hydro energy. So we are not using electricity for the densification process to run.
Oh.
But again, other things will come into play here, right?
Mhm.
From
Mhm.
where we are harnessing the water energy. Is the energy sufficient for the screw press or even the piston press to generate that pressure? Because if you remember, the pressure is quite high for
Mhm.
piston press.
Mhm.
So if you are talking about animal, right? So it is cost effective way, but does it really giving you that high compaction process? Because there is a associated energy with every process. So if you're using animal source or some other less intensive processes to run densification process,
Mhm.
you have to make sure that that energy form or the process which you are inputting is generating the pressure which is required. Our goal here is to generate that high compaction rate. Because if you're going for low pressure, right, as we understood here, if you're going for low pressure, we need binders, correct? The binders will again add cost to your raw material. But if you have agricultural waste, then you do not need to worry about the binders, because the organic waste is already rich in carbohydrate and it will
Mhm.
self adhesion, because the adhesive forces will be more and it will self compact if you're providing the pressure. So here what I can suggest, and I think you can read more on it, it is just my viewpoint, that if you have organic waste and if you're going for intermediate presses, right, and not high pressure densification, you can actually reduce the cost of densification.
Okay.
Yeah. So when you're talking about the cost, you need to look the whole picture and not the only uh, uh, cost
Cost
associated
consumption.
with that particular operation, right? Because at
Okay.
the end of the day, there will be always trade-off. If you need higher quality, you need to put more energy. But if you are
Mm.
compromising with the quality, you can also compromise with the machinery or the process which you are doing. It's directly related. right?
Yeah, I understood. Yeah. Thank you.
Yeah, no problem. So, what was carbonization and why we need carbonization? Anyone? Anyone remembers what was carbonization? Okay, so as till now we discussed briquettes, right? Briquettes at the end of the day, they are just the pelleted, solidified, having particular dimension, raw material form only, right? So if we are burning it, there are certain disadvantages associated with the briquettes itself. Some of the disadvantages are increased generation of smoke, because we have not subjected it to any other pre-treatment. Reduced ignition and burning properties. Why? Because we haven't segregated it that much. Low heating value. Obviously, if they are heterogeneous in nature, it won't give us 100% of what the raw material is comprised of, or the heating or the energy it is comprised of. And again, not stable under wet condition. Why it is not stable under wet condition? Because these products are very much hydrophilic in nature, and by hydrophilic I mean water loving. You know salt, right? Salt is ionic in nature. So during rainy season, what happens is the salt gets clumped up. Why that clumping occurs? Because it absorbs water, it absorbs the moisture, and hence the clumping occur. Similarly, with other powdered form or granulated form of things, they absorb water because they have very high surface area through which water can enter. Same thing will happen for the pellet or the briquette. So carbonization, it is basically a partial pyrolysis, and burnable gases like CO, CH4, H2, formaldehyde, and all these will be released when we pyrolyze the briquette. And with this, what will happen? It will give us more uniform heating of the briquette. It will provide less smoke, and it will absorb less water, right? So what exactly is the process? The off gas, again, everything we need to use, whatever is generating, whatever is there, at the end of the day we need to use everything. So these gases which I mentioned here, they can be reused for giving energy to other unit operations, or even self igniting processes. There are two different types of carbonization processes for briquette. First one is in which carbonization occurs, then the grinding will happen and the briquetting will form, which means the briquette at the end of the day won't have these commodities in them. Second process is we'll grind it, we'll briquette it with the processes which we have discussed earlier, and then we carbonize it, right? So this is the change before and after carbonizing the briquette, right? So in the moisture content, we can see that they provide intermediate processes. Similarly, with the mean ash content, volatile matter, as well as fixed carbon content, right? These are some representative pictures, and I will highly suggest you guys to just Google it once. It will give you more. If we see things, we relate more to it. Just spend some time on the internet and search these terminologies. It will help you in learning, right? And I guess we can switch to questions today. I wanted to discuss other slide also, but I guess we can go back to the slides itself. Okay, can you guys see the slide?
Yeah, ma'am.
Cool. So we will discuss some of the representative questions from the previous year. Okay. So what will be the answer for this first question? ideal Brayton cycle can be described by the process steps. I haven't discussed this uh, part today, but I hope you guys remember. Okay, okay, I have some answers. More answers, at least 50% participation. Yeah, at least try to attempt. Obviously, I will give you the answer, but more answers, please. I have received few answers. Okay, the answer is isentropic, isobaric, isentropic, and isobaric. We are talking about the ideal Brayton cycle. So if you remember when we were talking about this process, this Brayton cycle was discussed. Here the first step from first to second was isentropic. Second was isobaric. Third and fourth, again, they were isentropic. And fourth to first, it was isobaric. I hope you guys know these basic terminologies about isentropic and isobaric. And if not, then here are brief definitions for it. So what exactly is the isentropic process? Isentropic is a thermodynamic process in which the entropy remains the same. While isobaric process, it is a process in which the pressure of the system stays constant. That is, change in pressure will be zero, right? Now, some coming to next question. Arrange A, B, C in bottoming cycle. So what was this? Bottoming cycle, topping cycle, congression, all those things, right? So I hope you guys remember. So what is A, B, and C? Is it furnace, heat recovery, and turbine in the following manner? Is it furnace, turbine, heat exchanger, furnace, compressor, heat exchanger, or furnace, heat recovery, boiler, compressor? Okay, I have few answers, few more. Even if it is wrong, don't worry, just try to attempt it and try to remember where you studied this, what was the context of it. Um, okay, few more answers. Try to attempt. Okay, the answer is furnace, heat recovery, and boiler turbines. I guess you guys gave the right answer. So if you do not remember where you studied, this was the part of the slide where you studied about the bottoming cycle and the combined cycle. In this, what happens is we basically take heat prior sending it to the turbine for the production of electricity and power. This was bottoming cycle, while topping cycle was we generate electricity and the power and then we subject it to the heat recovery operations. The third one is the process for simultaneous generation of electricity, useful heating and cooling from the combustion of fuel is known as carbonization, densification, trigeneration, or cogeneration. Okay. Try to attempt it. And even if you do not know the meaning of exact terms, Just try to relate to the things which are asked in the question and relate to the processes from their name. Okay, I have few answers. More. I guess people are a bit confused. I would like you to reread the question, right? There is one aspect which is distinguishing from the processes which are confusing here for you guys. The process for simultaneous generation of electricity, useful heating, and cooling from the combustion. Okay, the correct answer is tri-generation. And for you guys who are confused between cogeneration and tri-generation, remember cooling was the aspect which is associated with the tri-generation and not cogeneration. Cogeneration is having electricity, heating, power, and then again heating, while tri-generation was also cooling it and then subjecting it to the uh, uh, power production. I will I will suggest you guys to go back to the lectures because these are some of the things which are very like very less different from each other, and they are sources of confusion. So just go back to the lecture once, then it will be okay for you guys. The next question is based on compaction. The briquetting technologies can be divided into first high pressure compaction, medium pressure compaction, low pressure compaction, or all of the above. This we discussed right before jumping to the questions. More answers, at least this, yeah, okay, I started receiving some answers. More answers, at least 50% participation minimum. We have discussed it today. This is the hint. And we have also discussed like on what basis, as the name suggests, like on what basis they are classified or divided. Okay. The answer is obviously all of the above, as we have discussed high pressure, medium pressure, and low pressure. Low pressure was 5 megapascal, medium pressure was, I guess, 5 to 1000 megapascal, and high pressure was more than 1000 megapascal. Sorry, 100 megapascal. Sorry. Yeah, so you can look at the slide here, and also you have to remember the basic range because you do not have to remember numbers everywhere, but you have to remember numbers and range where they are the criteria for classifying things, right? Here, the criteria for classifying is the pressure itself. So you have to remember the pressure range for high, medium, and low. Then we have discussed it today. Identify the briquetting process technology in the figure given below. Is it a screw press, piston press, rotary press, or none of the above? Few more answers. Yes, correct. And I will appreciate if you guys can tell me what was some key features, or just say what was the disadvantage of this process, because that is one of the biggest disadvantage of piston press, despite having high pressure uh, densification process. I am repeating myself multiple
It's not
times.
the continuous process. That's why it is.
Yeah. I'm repeating myself most of the time and I'm being redundant. I know this, but just to help you out, guys, so that things stay in your mind for longer duration of time. because if we repeat, we tend to remember it well. Yeah, correct. Yeah, so I don't think we need to discuss much upon it. We have discussed it earlier. It is a piston press, and you can go back to the lecture if you want to understand more of it. And I will again suggest you to go to the YouTube and search piston presses, and you will get some live examples and the live machineries, how they look and how they function. So what is a friability index of 1 indicates? Is it adequate briquette quality, inadequate briquette quality, moderate briquette quality, or best quality briquette? We haven't discussed it today, but I hope you remember Professor Mandal's lecture. Okay. More responses. Okay. Few more answers and then I'll tell you the direct answer. And try to remember what was friability also. What was the context of friability? Um, the correct answer is inadequate briquette quality. For those who have said that it is best quality or adequate quality, just remember friability is the measure of the material which has not dropped from the sieve or which is retained in the sieve, right? So nothing is retained, which means nothing is retained, everything is in the powdered form. And hence we do not need such quality of briquette, because during transportation, what happens if we are transporting such kind of briquette, due to the transportation, what uh, exactly, see, at the end of the day, we do not have highways and all those things and smooth roads and everything, right? There is some mechanical stress always associated when we are transporting raw material, goods, or any other thing. So we need to make sure that our product is sustainable in such conditions, right? So if nothing is retained, which means even with a little bit of shock, the briquette is disintegrating. That is why it will pass through the sieve, right? So if nothing is retained, it will pass through the sieve. Hence, it is not at all sufficient for transportation. And indirectly, we can say that it is not a good quality briquette. And if you do not remember, just go through this slide once more and you will remember why the friability index of 0 is inadequate, while 20 is good quality. Why 20? Because we are using a sieve of 20 mm at the end of the day, right? Hmm. Next question. It is again from the same part of the lecture. Immersion test is used to understand the heating value of briquette, friability of briquette, resistance to humidity, or bulk density of briquette. Immersion test. Try to understand the meaning of the word itself, immersion. Immersion is often associated with uh, dipping something. Mostly it will be water, right? So often water is associated with which property? Is it heating value? Is it friability? Is it humidity? Or is it bulk density? This is a very huge hint for you guys. Yeah. Okay. Few more answers. some other people who are not uh, trying to attempt, I will encourage you to at least try to attempt to answer these questions. The answer is resistance to humidity. If you remember the immersion test in the last part here, it was basically we are dipping the briquette in water for prolonged time and we are measuring the swelling or the elongation, and this is the criteria to judge whether the briquette is of good quality or not. Why we need to judge the resistance to humidity? As I mentioned, during the transportation, the weather conditions are different. Hence, your product will be exposed to environmental conditions. Second, wherever you are storing your briquette or your product, the humidity or the surrounding temperature and all those conditions are not necessarily will be regulated. Hence, your product needs to be stable in those conditions. For such thing, we do immersion test, right? Our next question is of numerical based type. These questions were discussed in the week 4 lecture itself. I will give you guys 5 minutes to try to attempt this question and then we will solve it together. Okay. Your 5 minutes starts now. And if you guys do not remember the formula, I have kept it here. But for future references, I will suggest you to keep a separate sheet or at least notes in which you have all the formulas written somewhere all together so that it will be accessible to you guys. Now try to put the values and mold the formula according to whatever is asked here. Just try to attempt it, even if it is wrong. Do not worry. We will discuss the solution. Just try to attempt it. 5 minutes are over. If anyone wants to just even guess a little bit, just give it a try. The answer is 3.76. Those who have said D, I will recommend you to just recheck your calculation, because in this, we just need to put the quantities which are given to us in this formula directly, and it will be 3.76. Yeah. So I don't think anyone has doubt in this, because it is directly putting the values which are given here in the formula. The only caveat of this is that you need to remember the formula for such kind of questions, right? This next question is also a numerical type question. So, 10 tons hydraulic jack was used to lift the machine components and compress the briquette. Pressure read from the pressure gauge connected to hydraulic jack was 20. The machine has 20 molds. Find out the compaction force. In this, there is no direct formula, but there is manipulation of one of the basic formula. This is one of the hint. Just try to attempt it. Again, I'll give you guys 5 minutes for this. Try to attempt and remember what is the formula for pressure, and you will get to the end of this. Yeah, your time starts now. try to attempt even if it is wrong. Any answers? Remember, pressure is equals to force upon area, and we need here force generated by 20 such machines, 20 such moles, I mean. Any answers, even one single answer will work. Okay, at least someone attempted it. Anyone else want to send their answer? Otherwise, I will discuss it. And a similar problem was discussed in the lectures also. So if you guys are not able to attempt the question, I will highly suggest you to go back to the week 4 lectures. And I guess first 2 lectures were dedicated to problem solving. Yeah. So the answer is 246. And I guess whoever attempted it, they might just have like used the calculation might be wrong, but your concepts would be right. So how this was solved, and if you do not remember this, again, they are directly from the lectures. So let's assume that compaction force is Fc, compaction pressure is Pc, total compacted area is Ac. So what will be the compacted area? Compacted area will be the number of moles we have, or the number of moles, I mean moles, sorry, number of moles we have, and the cross-sectional area of each mold, right? Or each product. Here it will be briquette. So as I said, pressure is equals to force upon area, right? So we need to calculate the force. So force is pressure into area. So pressure for one compaction is 20 kilonewton per meter square, right? And the area will be pi by 4 into d square. I hope, because it's a circular sphere, right? So it will be this. So d is, as in this diagram, in this formula only, d is the diameter which is given, and you just, and pi value we know it's 3.14. So if you directly put the values in this area or the force formula, you will get 246 Newton. It was not a difficult question. You just need to know the relation between pressure and area. So if we know the pressure or the force generated by one mold, we just need to multiply it with the number of mold which are available in the machine. It was basic. You do not need to remember any particular formula. It was a very generic formula which you need to remember. So this is the last question for today. This is also a numerical type question, and it's a bit long, but it is not difficult. Again, in this, you do not need to remember any particular formula, but know the concept of moles. That's it. You need to know the molecular weight of constituents present and the concept of mole. The question says, pine needle is used to produce bio oil in a slow pyrolysis unit. The percent of bio oil, char, and gas are 35, 40, and 25 respectively. The average molecular formula of the biochar is determined as given, right? And for bio oil, it is given. The composition of gas also is given. So we need to calculate the percentage of carbon converted to bio oil. So it's a bit of a long process, but remember that we have the percentage of components, we have the molecular formula of the components, we can take moles from these two given things. If we have carbon and we know the composition of gas also, so if we know the composition of gas, we can find the total carbon available from bio oil, char, and gas. If we know the total carbon available in these four products, we can know the percentage of conversion. Just try to attempt. It is bit long, but as I mentioned earlier, such type of questions have been discussed in the class. So I hope that you guys know how to even try to attempt it and start solving the question. I'll give you 5 minutes, but the time is not restricted. Just let me know if you need more time. But initially, I'm giving you 5 minutes. I hope you guys are able to attempt it even. Just try to attempt. It's not a difficult question if you remember the basic flow of the question and what at the end what you need to calculate the percent of carbon converted. You need the percentage of carbon available to you guys. 2 more minutes and then we'll discuss the question. Till then, if anyone has attempted and try to give the answer, please do send in the chat box. Anyone wants to send their answer? Okay, I guess most of you have tried to attempt it. I hope so. And even if the answer is wrong, don't worry, we'll discuss it. And even if you do not understand it here, the discussion class is tomorrow, and also go back to the lectures. And even then, if you're not able to clear your doubts, we can discuss this in the next class. Okay. So if you guys were gonna give me answer fourth, then most of you will be correct, right? And as I mentioned, what is the basic thing which we need here in these type of problems is that we need to know the carbon percentage at the end, right? So for carbon percentage, we need to know the available carbon to us. And for us, there are three uh, products in which carbon is there, right? Bio oil, char, and gas. And the constant of all of them is given. So our basis will be 100-gram pine needle because everything is in percentage. So we assume that everything will be like 100%, hence 100 gram. So bio oil is 35 gram, char is 40 gram, gas is 25 grams, right? The molecular weight of bio oil will be, the bio oil constituent is given as this formula, right? CH 0.05, O 0.28, N 0.013. So what will be the weight of this? Carbon weight, which is 12, plus hydrogen weight, which is 1 into 0.56 times, plus oxygen weight, which is 16 into 0.28 times, plus nitrogen weight, which is 14 into 0.013, right? And then similarly for the char and all those commodities. So first we'll talk about the bio oil, which is given here. So the bio oil weight will come around 19.3. We have the weight, right? And we have the weight available to us or the produced weight. So we can calculate the moles. Thus, so 35 gram of bio oil will be 1.813 moles. Correct? Similarly, with the char, the molecular weight of char can be calculated similar to the molecular weight calculated for the bio oil, which will come around 17.2 grams, right? And char available to us is 40 grams. So the moles of char will be 2.23 moles, right? Now last will be for the gas. For us, the weight of the gas is given here, which is 20, 36, 25, 19, right? We need to put all these things along with their molecular weight. So for H2, it will be 2. For CO2, it will be 44. For CO, it will be 28. For CH4, it will be 16. I hope this is clear. It will be 26.28. And we have gas with 25 grams gas. The moles of the gas will be 0.95. Correct? Now we need to calculate the volume percent and the mole percent of gas. So H2 is it's 20%. This is given here 36%, 25%, and 19%. Thus, 1 mole of gas will be having 0.2 moles of H2, 0.36 moles of CO2, 0.25 of CO, and 0.19 of CH4. Now, as I mentioned that at the end we need the carbon, right? So carbon present in bio oil is 1.8, in char it is 2.3, and in gas, as gas has other components also, so the total will be 0.9 into 0.36 plus 0.25 plus 0.19, right? It will be the total carbon in the gas itself. Now, total carbon will be the carbon present in bio oil plus char plus gas. It will give us 4.89 moles. Now we have total moles, right? And we need to convert the percentage of carbon converted. So percentage will be the total moles, right? This will be in denominator, and the numerator will be the total moles in the your bio oil, right? Bio oil here, your bio oil is 1.813. So 1.813 into 100 for percentage divided by the total moles available for carbon. It will give us 37% or 37.03 to be exact. I know this is a bit long question, but at the end, remember what they're asking. They're asking for the percentage of carbon, right? Converted to bio oil. So we need to know, first of all, we need to know the total carbon. Total carbon will be coming from oil, char, and gas, right? If we know the total carbon and we know the carbon in the bio oil, then we can easily get the percentage. The percentage is basically the percentage of carbon in bio oil divided by the total carbon produced into 100. I hope that this is clear to you guys. And if not, I will highly suggest you guys to come and attend tomorrow's lecture also. And even if you do not like if you're not understanding some concepts or certain things, go back to the lectures, try to understand. Otherwise, you can write to us. Okay. I'm staying here for 2 to 3 minutes if anyone wants to ask anything or discuss anything. And from my side, for today, this is all. And if you want to leave, you guys can leave and go. Thank you for your patience. If you want to go, you guys can go.